Hello everyone, you've made it to properties of parallel lines. In this lesson we're going to build on our special angle pairs that we learned in the previous lesson, but this time apply it towards angle pairs that are created by two parallel lines and a transversal. You see this all around you. You see this on the streets you drive on, the sidewalks you walk on. Okay, so start noticing those things when you're out and about. Before we begin, it's essential for you to understand that the special angle pairs formed by parallel lines and a transversal are congruent, supplementary, or both. Our first postulate that we're going over is corresponding angles postulate. Now, if a transversal intersects two parallel lines, then corresponding angles are congruent. So if we have line L is parallel to line M, then it states that angle 1 is congruent to angle 5, angle 2 is congruent to angle 6, angle 3 is congruent to angle 7, and lastly, angle 4 is congruent to angle 8. Now, alternate interior angles theorem states if a transversal intersects two parallel lines, then alternate interior angles are congruent. So if we have line L is parallel to line M, then we have angle 3 is congruent to angle 5, angle 4 is congruent to angle 6. So let's prove the alternate interior angles theorem. We're given that line L is parallel to line M, and we want to prove that angle 4 is congruent to angle 6. So looking at our diagram, we have our line L and line M cut through by our transversal, and we see the angles that are created by it. I'll set up my two-column proof and start with what's given. Line L is parallel to line M. I'm going to take away some of the angles so we can focus on angle 4 and angle 6, and I'm going to keep one that relates to both of them, which is angle 2. We can say angle 2 is congruent to angle 6 because if lines are parallel, then corresponding angles are congruent. I'll put back our angle 4 because angle 4 is congruent to angle 2. Why? Because vertical angles are congruent. Now we can finally say that angle 4 is congruent to angle 6 because of our transitive property of congruence. Now if we know this theorem, we're able to also prove alternate exterior angles are congruent based on vertical angles theorem and the transitive property of congruence.